Hey guys, in this video we're going to be talking about systems of equations, and a system of equation is two or more equations that have the same set of variables. So an example that I have here is these two equations, y equals 2x plus 1 and y equals x plus 5. Now in this case the x's mean the same thing and the y's mean the same thing. These aren't two separate functions where x can be something different in each equation. Here we're talking about two equations that have the same variables. So what we're going to try to do today is solve a system of equations, and that means that you find an x value and a y value that is a solution to both or all of the equations in the system. So we would ask ourselves, what x and y value make both of these equations true at the same time? So there's a lot of different ways we can do that, and one of the ways that we're going to do that is to do it by graphing. We're going to graph both of these functions on the same coordinate grid, and we're going to see where they cross. So the solution to this example that I have is 4, 9. That pair of values makes both of these equations true at the same time. If I put 4 in for x in this function, I get 2 times 4, which is 8, plus 1 is 9. So my y value is 9. And if I put 4 into this function, I get 4 plus 5, which is 9. So you can see that this ordered pair is a solution to both of these equations. So that's what we're talking about when we talk about finding a solution to a system of equations. And how we're going to do that today is by graphing them. It's probably the easiest way to find an ordered pair that's a solution to both. So to do that, we're going to graph each equation in the system on the same coordinate grid. And then we can use slope-intercept form, we can use x and y intercepts, a table, etc. We've learned a lot of different ways to put a function onto a graph. So just take your pick. We found that slope-intercept form is probably the easiest and fastest way to do that, so that might be the preferred method. And once we do that, we just simply have to find the point where the two lines intersect or cross. And that's going to be the solution to the system, because that point is on both of the lines. So it's going to make both of the equations true at the same time. So let's take a look at this system right here. Y equals 3x minus 3 and x plus 2y equals 8. We want to find out what x and y value makes both of these equations true at the same time. So the first equation, y equals 3x minus 3, is already in slope-intercept form, so that's a bonus. So I'm going to go ahead and graph that. I know the y-intercept is at 0, negative 3, so I'm going to go ahead and put that point on the line. And I know the slope is 3, so that's a rise of 3 and a run of 1. Rise of 3, run of 1. And so now I got an idea of where my line is, so I'm going to draw that line. And then you may have noticed that the second equation is not in slope-intercept form. So if I want to graph this using slope-intercept form, then I need to change this to get it into slope-intercept form. So it really doesn't take much to do that. So I'm going to go ahead and do that. I got to get rid of the x on this side of the equation because, again, remember, I want to get y all by itself. So I'm left with 2y equals negative x plus 8. I'm just going to keep that x term in front, so I flip-flopped them there. And then I have to divide everything by 2. And we learned how to do that in the last video on getting equations into slope-intercept form. So I have y equals negative 1/2 x plus 4. So now this function is in slope-intercept form, and I can go ahead and graph that. The y-intercept is going to be at 0, 4, 1, 2, 3, 4. And my slope is negative 1/2. So that's down 1 over 2, down 1 over 2. So now I can see where that line is, and it's pretty clear to see where these two lines are going to cross or intersect. It's very important to be as accurate as possible when drawing your lines. You've got to make sure you use a ruler, otherwise you're going to get the wrong location on your grid to find out where these two lines cross. So I can see that these two lines cross right here, and this is the point 2, 3. So I can tell that is the point that is going to make both of these equations true at the same time. Now, if I wanted to make sure and double check that, just to make sure I got the right point and my graph wasn't inaccurate, I can go ahead and just plug these values into both equations to see if they work. So if I plug a 2 into this first function, 3 times 2 is 6, and 6 minus 3 is 3. So that is a solution to the first equation. And if I plug it into the second equation, I get 2 plus 2 times 3, and 2 times 3 is 6, plus 2 is 8, and it is a solution to the other one as well. So it is a solution to both at the same time. So I know 2, 3 is the solution to this system of equations. So every system of equations is going to have an ordered pair as its solution, or in other words, the location where both of these are true at the same time. Let's take a look at this system of equations, and we're going to notice something a little unusual about these. These are both in y-intercept or slope-intercept form, excuse me, so that should be easy to graph these. My first one, y equals x plus 4. My y-intercept is at 0, 4. 1, 2, 3, 4. And I have a slope of 1, so that's up 1 over 1. Get a few more lines or dots, and I'm going to draw my line. And my second equation is in slope-intercept form, y equals x. This has a y-intercept of 0. I'll use a different color, 0. And a slope of 1, up 1 over 1. And maybe you've already noticed this is a problem. These two equations have the same slope, but a different y-intercept. Where are these lines going to cross? Well, they're not. They're parallel. So these lines will actually never cross. So what do we say when we run into this situation? Pretty easy. We say there is no solution. There is no set of ordered pairs that will make both of these equations true at the same time. Because in this function, y and x have to be the same number because y equals x. And in this one, y will always be 4 bigger than x because you're adding 4 to x. So they both can't be true at the same time. Y can't equal x, and y can't be 4 bigger than x at the same time. So that kind of makes sense that there is no solution to this. So whenever you run into parallel lines, that's going to be no solution. Look at these two equations. My first one, again, is in slope-intercept form. My y-intercept is 0, negative 1. And my slope is 1/2. That's up 1 over 2. Up 1 over 2. That line is right here. And again, my second equation is not in slope-intercept form, so I need to get it into slope-intercept form. I'm going to get rid of this x term. And I have negative 2y equals negative x plus 2. And I'm going to divide everything by negative 2. Get rid of that coefficient. Y equals 1/2 x minus 1. You'll notice that I get the same equation as the other one. These two equations are identical. So again, if I go to graph this, I'm going to basically come up with the exact same points, and it's going to be the exact same line. So where do these two lines cross? Well, the answer to that is everywhere. Okay, these lines cross at every single point. So how many points or ordered pairs are going to be a solution to both of these? Well, there's an infinite number. There's an unlimited number of solutions to this system of equations. So we just say, in this case, there are infinitely many solutions. So when we run into the same line, that we have infinitely many solutions. So there are 3 different possible outcomes to solving a system of equations. And they are, you have the first scenario where you have intersecting lines. And that's easy to see because if you're looking at the equations, they'll have different slopes. If your equations have different slopes, they're going to intersect somewhere. then there's one solution. They'll only cross once. If they have the same slope but different y-intercepts, that tells you that they're going to be parallel and there is no solution. They will never cross. Or if they have the same slope and the same y-intercept, they're the same line. So then they cross each other everywhere, and we say that there are infinitely many solutions to that system of equations. So this is one method to solve systems of equations, and that's by graphing. And we're going to run into three possible outcomes: one solution, no solutions, or infinitely many solutions.